Morning, everyone. How y'all doing? All right. My name is Robert. I am a software engineer at the Facebook Boston office, where I work on GraphQL. I am really excited to be here with you at Conf 2017. And today, I'd like to talk about building real-time React apps with GraphQL subscriptions. This talk has 3 parts. The first, we're going to talk about why we're interested in building real-time apps and what we mean when we say real-time apps. In the second part, we'll talk about how we do it. What are the state-of-the-art techniques? Where does GraphQL subscriptions fit in terms of the landscape of the solutions that we have available? And to do that, we'll also look at some examples and some demos. And finally, I'll end with where we are right now, what the next steps are, and how you can start using GraphQL subscriptions to power real-time React apps today. Why are real-time apps interesting? They're certainly harder to build. So what makes the trade-off worth it? Well, I think it's because real-time apps give us a sense of presence. Like we're part of something as it happens. We're seeing something nobody else has seen before. And this gives us this feeling of connection to the moment, the event, the world, and other people. It's like the difference between watching a sporting event live versus watching it pre-recorded 3 weeks later. But just what do we mean when we say real-time app? Well, when I hear that word, a couple examples come to mind. Probably the first one is various messaging apps. When I have a conversation over one of these, it usually happens in real time. Another example is rideshare apps. Using these apps, we can see how far away the driver is. We can see how long it's going to take to reach our destination. And of course, all varieties of cooperative and competitive multiplayer games. But there are some less intuitive examples that we don't always think of when we hear that word. These might include email, Dropbox, navigation, and fitness apps. In all of these cases, the app depends on remote data that is valuable immediately after it becomes available. And we're no longer talking about the classic web app model, where the client issues a request, the server answers with a document, and that's it. In fact, the communication pattern between the client and the server in these applications resembles a conversation, a back and forth that lasts well after the initial request. It's no surprise that React has played a large role in enabling us to build better and more real-time apps. Over the last few years, React and the Flux architecture have changed how we think about building apps in general. Not so long ago, it was really difficult to build real-time apps, in part because we were using imperative UI frameworks that made it really difficult to manage data. But since React views are a function of state, the challenge of building a real-time app becomes focused on client-side state management and having a really good real-time API. Since there are mature client-side state management solutions, such as Relay and Redux, I'm going to focus on talking about the API. There are 2 general categories of real-time APIs, push and pull. And among push-based real-time APIs, we can further subdivide them into live queries and subscriptions. Let's take a closer look at all 3. Imagine we're building an email app. And on the client, I'd like to display the number of unread email messages in my inbox. And this number changes over time, like so. The simplest way to do this is to poll. And this is where the client asks the server, how many unread emails do I have periodically, like so. Let's make a few observations about this approach. The first is that we don't capture every state transition. Notice the value jumping from 1 to 3. The second is that after the value is available on the server, it might be a little bit of time before the client asks for that value again, therefore resulting in latency. And the third is that some polls do not actually yield any new or useful information. Now at this point, you might be thinking, polling doesn't count, or polling sucks. But I would encourage you to pause for a moment. Polling has the advantage of being simple, stateless, and intuitive. And as a result, it's very useful as a prototyping tool, as a fallback solution when your fancy push-based solution breaks, and as a full-scale solution when data changes at a known frequency. How can we improve polling? Let's take a look at that very first problem where we missed some of the state transitions. Naively, I could just poll a lot faster. But what I notice now is I have even more waste. All of the blue requests are not telling me anything new about the state on the server. But the red requests did yield new information, and I want to keep those. So how could I optimize this? Well, if I had a stateful channel between the server and the client, and I could detect when that data changes, then I can build what we call a live query. And it looks something like this. Conceptually, it's just like the last slide, except that we've gotten rid of all of that waste. Now, to build live queries, we need reactive backends. And that makes live queries challenging to integrate and scale. Let's consider what happens if we have a different requirement. We want to display the number of unread messages only when we receive an important email. Now, I'm sure if you're like me, some emails you receive are more important than others. So if you receive a mix of important and unimportant emails, here's what the timeline might look like. And if we only push data when we receive an important email, we're describing a system that more closely resembles an event-based subscription. Let's make two observations about this approach. First, we're not detecting every state transition. Second, when data is pushed from the server to the client, we know exactly why it was pushed, what caused this to happen. Now that we've covered those approaches, we find ourselves with two push-based solutions. Who here loves APIs with multiple inconsistent ways to do the same thing? Okay, so we should ask, are subscriptions and live queries actually the same thing? Can they be unified? And to answer that question, let's look at it from the client's perspective. As a client using one of these APIs, do live queries and subscriptions have different contracts? Think about that for a moment. For a live query, I expect every state transition to be pushed once I execute a live query. But for a subscription, I only expect the state transitions associated with the event to be pushed. And then when that data is pushed, I know the reason why it was pushed. Because of these semantic differences, I think live queries and subscriptions are two different tools in the Realtime API toolbox. Now, nothing we've discussed so far is new or controversial, but we needed to establish some fundamentals and some terminology before we dive deeper. Now let's go into event-based subscriptions in more detail. Suppose we have a client that's subscribed to an event. When the event triggers, what do we tell the client? Well, we have a few options. We could tell it as little as possible, perhaps just the ID of the thing that changed. And in response, the client might evict this entry in the client-side cache. And to repopulate that entry, it might have to issue a subsequent network request. Now this works, but it results in an extra network hop, which results in latency. But we commonly see this pattern being used by systems that heavily depend on the Pubsub pattern. Another option is to send the exact same data to every subscriber per event. And this works well when we have publicly available data and everybody should see the same data. But one of the problems with this approach is that we might be sending extra information that the client doesn't need. In this example, if the bio field contains a lot of text and we simply don't display it on our mobile clients, then we're wasting valuable network resources. Another dimension to consider is whether the payload, the data that you're sending to the subscriber, varies between subscriber. If we're trying to send a piece of information like unread email count in your inbox, this number is unlikely to be the same between any two given clients. As we consider these requirements, we're starting to see a very familiar problem start to form. How do we avoid sending the client too little or too much data? What if we had a way to let clients specify exactly the data that they needed? Well, we do. It's called GraphQL. Now, can I get a show of hands? How many in the room have heard of GraphQL? Okay, that's a lot of people. For those of you who aren't familiar with GraphQL, don't worry. It's an elegant idea for a more civilized age. GraphQL is a declarative data query language that lets clients specify exactly the data that they need. Let's go over the basics. My favorite way of introducing GraphQL is through a technique I call wish-driven design. When I'm building the client, I like to imagine the shape of the data that I wish I had. Now keep in mind, I'm extremely lazy. So the shape of this data ought to be in the exact shape that I can pass into my React component as props. So if we were to build an email client and I wanted to display a list of emails, I might wish I had a JSON object that looked like this. Now that I know the shape of this object, I'm going to strip away the value portion of this object, the value half, the right side, like so. And if I clean up the double quotes and get rid of the commas, this is what I'm left with. Now I'm just going to do one small thing. I'm going to add a root GraphQL type to this. And voila, I have a GraphQL query. Now the client sends this query to the server. And in response, the server returns a JSON object in the exact shape with the exact fields that the client asked for. No more, no less. Now that we've seen a GraphQL query, let's take a quick look at what a subscription looks like. Pretty similar, right? We have a different root type, subscription, instead of query. And we have a root field called important email, which allows us to map to the event or set of events that will trigger this subscription. What this subscription is saying is when certain events occur, fetch the from, subject, and isRead fields from the important email that just arrived. When talking about GraphQL, slides are okay, but demos are much better. Or as Morpheus likes to say, unfortunately, nobody can be told what GraphQL is. You have to see it for yourself. Can everyone see the screen okay in the back? Yeah? Okay. On the left here, we have a really simple email client built with React and our newest version of Relay. And as you can see, we've got several emails, and for each email, we display the from, who it's from, the subject line, and the body. And on the right, I have graphical. Graphical is the GraphQL IDE. Graphical allows us to explore a GraphQL schema. Now, a GraphQL schema is just a set of GraphQL types, the set of fields they have, and how they relate to one another. Let me show you. I can use the Graphical Documentation Explorer. And if I click in here to fields, to queries, to inbox, I can see that inbox is of type folder. If I click through here, I can see folder has a few fields: ID, name, and unread count. Knowing that, I can come in here and I can execute a query, just like the ones that we saw in the previous slides. So I can say something like inbox, unread count, me, and then I can edit. I can execute it. Check out this field down here, emails. Emails claims that it returns a collection of emails. And if I click through to email, it says it has fields ID, arrived on, from, etc. So if I wanted to grab all the data that I needed to populate this sample app, the sample email app on the left, I can just come in here and say emails from subject. And now I have all the data that's displayed on the left. We also saw a subscription. Let's see how that works. So that's all I need to do in order to execute a subscription. And if I actually run it, unlike a query, it's not going to come back with data immediately. Because remember, the subscription runs in response to when the underlying event triggers. So if I run it, nothing's going to happen because this is not a real email server. But I can start sending some demo emails. And to do that, let me show you the third root type in GraphQL, the mutation type. I have a very simple mutation here called start demo. It takes 0 arguments, and it'll start sending me sample emails. Now, the mutation is typically how we do writes in GraphQL. So when I execute this, you're going to see a response come back as though it were a query. Cool. Now let's pray to the demo gods. Here we go. Yeah. Now we see some responses coming back. So you can see that this unread email count here. Okay. Now, it might not be clear to you just from looking at graphical how you would integrate GraphQL subscriptions with your React app. And to do that, to show you how that looks like, we're going to write some code together. Now, before I dive into this code, I want to mention that production React apps typically use GraphQL with some sort of client framework, such as Relay or Apollo. In the example we're going to look at, we're going to focus on the underlying fundamentals rather than a specific framework. Can everybody see that okay? Oh, oops. Let me, okay. Sorry, skipped over a slide there. Somewhere in your React app, you probably have the opportunity to receive data from the API and to add it to your store. And we're going to call this function modify flux store. And since there are so many valid variations of how you organize your state, we're just going to stub that out with a console log. Next, I'm going to add a really simple function that just does 2 things. First, I'm going to new up an instance of a subscription. And second, I'm going to subscribe to that subscription, passing it the modify flux store as the callback. What this means is that whenever the subscription triggers and the server pushes me new data, I'm going to invoke the modify flux store and pass that data in. Now, the subscription class we're looking at here is just an example. It's a very thin wrapper around the WebSockets transport between the client and the server. Lastly, of course, I need to specify the actual subscription query that we're going to be looking at. And we saw that earlier from graphical. So I'm just going to stick that into the subscription constructor. Let's run it. The code on the left here should look very familiar. There's just a couple of variations that I'll walk through. We have some imports. We have this function here, init subscriptions channel. And as I said before, we're using WebSockets in this demo, so we have some setup that we need to do. I've hidden that all behind this function. Notice that we're using await async. Hopefully you were here for Ben's talk yesterday. And lastly, I'm going to call start subscriptions at the very end. I can start running this code like so. And these emails are still coming in because the demo is still running. The server is still pushing emails periodically. So notice that on the left, I've selected from and subject from the important email. And here I have from and subject from the important email coming back. So hopefully that gives you an idea of what it might be like to integrate GraphQL subscriptions with your front end. Cool. Where are we right now with GraphQL subscriptions? At Facebook, we've been operating GraphQL subscriptions at scale for over 2 years. It powers familiar features such as live likes, live comments, and streaming reactions on live videos. As a result, we have a mature understanding of GraphQL subscriptions, and we're confident that the concept is generally useful. Like React, GraphQL embraces the philosophy of incremental improvement. And to manage these incremental improvements, we have something called the GraphQL RFC process. The RFC for GraphQL subscriptions is the largest proposed change to GraphQL since we first open sourced it in 2015. Now, the RFC itself has been merged and is currently undergoing review and discussion on our GitHub repo. Once finalized, the specification will enable the community to build an ecosystem of GraphQL subscriptions clients and servers across a variety of languages, transports, and backends. Suffice to say, none of this would have been possible without the amazing support and contributions from the GraphQL community. If you're interested in following along or participating in the evolution of GraphQL, I suggest you check out this RFC. Our partners at Apollo, GraphQL, and Scaffold have implemented the GraphQL subscriptions proposal in its current form. And if you just can't wait to use GraphQL subscriptions, you should check them out. I hope you're inspired to try building more real-time functionality into your React apps. And I hope this presentation has helped you understand the different techniques available to you. Thank you very much for your time, and enjoy the rest of the conference.